Dear students, today we are going to discuss about integration. Integration is considered as the antiderivative, and already you are familiar with different types of formulas and to some extent some numericals using these formulas. So just to recapitulate the formulas, so I am giving here, and for the convenience of comparison, uh, the list of the formulas for differential calculus are given here. This is the list of the formula for differential calculus, and this is the list of the formulas for integration or integral calculus. These are the rules actually. These are not formula, but this is properties of differentiation. And this we can say formula, the derivative of the constant is equal to 0. And similarly here x to the power n, so n into x to the power n minus 1, derivative of sine x is equal to cos x. Similarly here in integration, integration of dx, that means 1. So integration of x to the power n is equal to x to the power n plus 1 divided by n plus 1. Integration of 1 by x equal to ln x, you can write log x also here, e to the power x as it is e to the power x, and so on. This formula already you are familiar in the previous standard. To some extent you have used this formula. Just for recapitulation I am giving here, and if you compare with trigonometric functions results from both differentiation and integration, then you see the dx of sine x is equal to cos x. If we differentiate cos x, then we must have sin x. If we integrate cos x, then we should have sin x, because integration is the antiderivatives. So integration of cos x, if you observe here, you see integration of cos x is equal to sin x. ddx of sin x is equal to cos x. ddx of cos x is equal to minus sin x. So if we integrate minus sin x, then we must have cos x. If we integrate minus sin x, so minus you can consider here, integration of minus sin x is equal to cos x. So integration of tan x is equal to sec square x. If we integrate sec square x, then we have tan x. If we integrate sec square x, then we have tan x. Integration of sec square x dx is equal to tan x. So that is integration is just considered the antiderivatives. So these are the list of the formulas from both differential and integral calculus, fundamental formulas, and you can note it down, and using some of these formulas we will discuss few examples. Let's take an example. It's a polynomial function, 4x to the power 6 minus 2x cube plus 7x minus 4 into dx. So we have to integrate this one. So here are 1, 2, 3, 4 terms are here in this function. So we can integrate term wise, the integration of this minus integration of this minus integration of this minus integration of this, that is 4. So one by one we can just integrate and just use the x to the power n formula. Very simple. Integration of first term, this one, 4 constant, so it remains as it is. X to the power 6, that is x to the power n, it would be x to the power n plus 1 divided by n plus 1, that means x to the power 7 divided by 7. So this is the result of the integration of the first term, x to the power 7 divided by 7. Similarly, minus 2 remains as it is. X to the power 3, same formula, x to the power n formula. X to the power n plus 1 divided by n plus 1. That means x to the power 4 divided by 4. So minus 2 divided by 4, x to the power 4, that is x to the power 4 divided by 4 minus 2 constant as it is. So this is the integration of the second term. And the third term, 7x, 7 constant as it is, x to the power n formula, if we put here, it would be x square divided by 2. So it is x square divided by 2. So this is the integration of the third term. And minus 4, this is the fourth term. Integration of the fourth term, minus 4, it's constant, it's as it is. So simply integration of dx, and which is basically x. So minus 4x, this is the integration of this term. And in indefinite integration, it is compulsory to add an integration constant, and that is c, which comes always with independent integrals. So this is the result of the integration of this example. Similarly, another example, if you consider here, this example number 2, z to the power 7, z to the power 11, z to the power 16, dz. So this function is in terms of z, so we are going to integrate with respect to z. So this dz represents with respect to which variable we are going to integrate. So the function is in terms of z, so we are going to integrate with respect to z. So very simple, same thing, x to the power n formula. So z to the power 7, it would be z to the power 8 divided by 8, z to the power 12 divided by 12, z to the power 17 divided by 17, z to the power 17 divided by 17, and plus integration constant. So this is the result of the integration of this example. Similarly, another example, say it's variable, consider t here, x, y, z, t, whatever it is, doesn't matter. Function is in terms of t, and we are going to integrate with respect to same variable t. So its exponents are in terms of negative, no problem. After all, it is x to the power n formula, because there was no restriction on n. So any number may be there in place of n. So it may be minus, no problem. X to the power n formula you go through, then we will have t to the power minus 3 plus 1 divided by minus 3 plus 1, that means minus 2, t to the power minus 2, t to the power minus 2 divided by minus 2, tan constant as it is. So this is the result of the integration of the first term. And similarly, t to the power minus 9 plus 1, that is minus 8, t to the power minus 8 divided by minus 8, 12 constant as it is, this 12 constant as it is. So this is the integration of the second term. And similarly, the third term, 4 constant as it is, and x to the power n formula you can apply here, t to the power 4 divided by 4 plus integration constant c. So this is the result of the integration of this function. Same thing, it is another polynomial with respect to w. The function is in terms of w, and we are going to integrate with respect to the same variable w. And again, it's x to the power n formula we can apply here. It's very simple. Next, another example here, if you see simply a constant, it's 12 dy, 12 is constant, so 12 you can write outside the integration sign, simply 1 dy, it's obviously integration of dy, it's y, so simply answer is 12y. And another example, if we see here, this, it's also involved with radical sign in terms of the variable w, and with respect to w we have to integrate here. So radical sign here, but no problem, after all we can convert into exponential form. So cube root of w, and this means w to the power 1 by 3. Again it is fifth root of w cube, so it's in exponential form w to the power 3 by 5. So uh, that means w to the power 1 by 3, that means x to the power again n formula. So this is also w to the power 3 by 5, that's also x to the power n formula you can go through. So ultimately this integration in exponential form, if we write, then we have the function of this structure. So now we can go through the x to the power n formula. So if you go through x to the power n formula, then it is integration of the first term w to the power 1/3 plus 1 by 1/3 plus 1, and w to the power 3 by 5 plus 1 divided by 3 by 5 plus 1. It's after simplification, it's very simple. uh, then we can have the function is, result of the integration is this one. Let's have a look on another example. It's a radical form, but we need to go through the same formula, x to the power n. This is square root of x to the power 7. That means in exponential form it is x to the power 1 by 7. 7 into 6 root of x to the power 5, that is x to the power 5 by 6. And 17 into cube root of x to the power 10, that is x to the power 10 by 3. So in exponential form this integral comes to this form. And now it is simply x to the power n form we can apply here. Integration of first term x to the power 7 by 2 plus 1 divided by 7 by 2 plus 1. Here also x to the power 5 by x plus 1 divided by 5 by x plus 1. Here also x to the power 10 by 3 plus 1 divided by 10 by 3 plus 1. And through when we go through this x to the power n formula here, then after simplification, simply we can have this one, the result of the integration. This one, another function, 4 by x square plus 2 into 1 by 8x cube dx. So it's in fractional form. Variables are given here in fractional form, but exponential form we can convert it so that you can go through x to the power n formula. So integration is this one. Now it is 4 by x square. It is after all not x to the power n form, but we can write in this way: 4 into x square. We can write here x to the power minus 2, and x cube is in the denominator, so we can write x to the power minus 3 as in the numerator. So now it is x to the power n form. So integration of x to the power n form, x to the power n form. So we can go through the x to the power n formula. It's very simple: x to the power minus 2 plus 1 by minus 2 plus 1, x to the power minus 3 plus 1 by minus 3 plus 1. So if you go through this formula, then after simplification you can have the result is this one of that function. So in this way already you have done in the previous standard so many examples. So just as a recapitulation, we are discussing few similar types of sums. Again, this one in fractional form, the function is given. It is just at a glance you cannot see that these are in x to the power n formula, but if we um, transform this in exponential form, then we can use directly x to the power n formula here. So definitely it is 7 by 3 into x to the y to the power minus 6, and it is y to the power minus 10, and it is y to the power 4 by 3 here in the denominator. So if we go to write in the numerator, it would be y to the power minus 4 by 3, y to the power minus 4 by 3. So this is the original integration, and we can simplify before integration. We can simplify the function in this manner, so that we can go through term wise using x to the power n formula. So integration of this, integration of this, integration of this. That is in case of all the terms we can use the x to the power n formula, and by going this we can have the result this one. So integration, term-wise integration of this one is this, integration second term is this, integration of the third term is this, and just after just minor simplification we get the result. This is the integration of the function. In another example, if the function is given in this way as the product form, and each one of these in polynomial form, then we can multiply the factors so that finally we get the actual polynomial. It is although in product form we should not go through the product rule as the first function and second function. So simply if we multiply the factors, then we can have a new look of the function, and that's this one. We get finally a polynomial function. So now simply term wise you can integrate. So this is the result of the integration. It's very simple. Similarly in this example also, it's at a glance it's a little bit might be confusing, but again it will be easy if we go through x to the power n formula. And before that, this product form we have to expand it to have its expansion. So if we remove this bracket and just multiply term-wise, so this into this, root z into z to the power 2 minus root z into this, and then we have the function actual form is this one. So just multiply term-wise, we have this one, and this is in the denominator. If we write in the numerator, then just z to the power minus half will be here. So now it is x to the power n. You can use the x to the power n formula here for the integration. Again in another example here, you see it's a polynomial, numerator and denominator is again polynomial. It's overall it's a rational function in terms of z, but the degree of the numerator is 8 and degree of the denominator polynomial is 4, so it's greater. So if we split term-wise, that is this divided by this, this divided by this, this divided by this, this divided by this, then if we split it, then we get this structure. Term-wise, 4 terms are there in the numerator, single term is there in the denominator. If single term is here and in the numerator more than 1 terms are there, then we can split it. So splitting this, we can have the actual form is this one. Denominators are z to the power 4. So after cancellation and simplification, this z4 will be cancelled out, z4 left, z4 cancelled out, z left, z4, z3 will be cancelled out, denominator z will be there, and here z to the power minus 4 in the numerator. So ultimately after simplification we get the function in this form. Now simply term-wise integration of this x to the power n form, integration of this x to the power n form, integration of this 1 by integration 1 by x formula, that's log x, integration of this x to the power n form. So in this way I can go through, and finally we get the result this one.